Welcome back to our next program of learning algebra. We have seen so far how numbers change their meaning with signs, and we have talked about infinity, we have talked about minus infinity, we have talked about integers, we have talked about whole numbers. This is Manish Kumar again, your tutor, presenting next class, and I would like to repeat again and again. Mathematics is all about practice, practice, practice. There are a lot of terms you will be coming across, there will be a lot of symbols you will be coming across, and we will be teaching you, we will be telling you, but this will be your effort, this will be your hard work, which you'll have to do along with this program to make sure that the learning of algebra is effective. So welcome back. In our last class, as I just now mentioned, we talked about numbers and signs. I just wanted to give some of the real-life example. I was setting off from my home this morning, and I went to a bagel shop. And what happened, I went to bagel shop, ordered for a bagel and ordered for apple juice. And then this guy said $3.50. So I said, fine. I took out my $20 bill out of my pocket, and I got bagel and I got an apple juice. But then I realized something is there which links me with my daily life here and bagel, right? I just saw that I had $20 in my pocket, and after I got bagel and apple juice, I had $16.50 because he charged me $3.50. So what was that? Why the amount was lesser now? So I thought about that. I started realizing about this. Then I thought $20 which was in my pocket. This is a corollary. $20 was a positive number, right? And then after I bought the bagel, I gave the bagel person $3.50, which was minus a negative number. My balance was $16.50. See, that's how you can correlate these things in your practical life. You can think about, whenever you think about numbers, think about money. Think about positive number as money in your pocket, negative number as money going out of your pocket. These are small, little examples which you can think of in your daily life. And then as you think more and more, you will see that you are learning algebra much more effectively, much more efficiently. Let's see what we talked about, or what was the quiz in our last class, and we'll see if we can try to solve that. Along with you, we will be giving some explanation for people who are able to solve it. That's well and good. For those who are not able to solve it, we will give you an example and detailed explanation of what and how to solve it going down the line. I hope that this will help you understand algebra better. Let's see. Our first question which we asked was infinity plus 1. What is the next number after infinity, right? The next number after infinity, what was the definition of infinity which I gave in our last class? It was one number more than the maximum number you know is called infinity. So that means, let's say if infinity was some number, then the next number after infinity, which is number 1, more 1 than infinity, is still infinity. So our answer is infinity plus 1 is infinity. Our next question. Identify the numbers. Look at these numbers and identify integers out of this. We have 1, 1.7, we have x, we have minus 30, and we have 0. Do you remember back our scale of negative numbers, the scale of positive numbers? Think that back. Remember that scale. And just try to think about which of these numbers were on that scale, and that is the answer. Integers are a set of our whole positive and negative numbers, which include 0 also. So let's see. Integers is a collection of positive numbers, which is 1 to infinity. Integers contain collection of negative number, which is minus 1 to minus infinity. Now remember, I'm using some of the terms, and we explained about this term, collection. Collection is something we collect. It's a very common term, but in mathematics, collection, set, these refer to same terms, and they mean that we have made a group of something. So whenever I use the word set or whenever I use the word collection, that means I'm talking about more than one entities. More than one entities for which I've made a set, or we have grouped them together as some entity, and we're calling them collection. Now integers are collections of positive numbers, integers are collection of negative integers, and integers also include 0. So let's see, out of these numbers, which one are integers, which one are non-integers. Number 1, that was there in our scale, minus 30, that was in our scale, and 0, that was in our scale. So which numbers were, or which symbols were not there as a part of our scale? 1.7, we didn't talk about that, right? Yes, we did not. So 1.7 is not an integer, and trust me, we'll be talking about that. We'll be seeing what 1.7 is. 1.7 is definitely not an integer. X. Now why x is not an integer? X is not an integer in itself. X as in itself is an alphabet. When we replace x with something, then it assumes some values. So if we replace x with 1, then we can say x is an integer. But if we say x is 1.1, it is not an integer. So x as it is, we cannot assume is an integer. So this was very important to understand what are integers, what are non-integers. Coming back to our next question. Our favorite question, plus plus minus minus plus plus 10. What does it mean? You remember our 2 tips. We talked about 2 tips in our last class. So we'll apply our first tip here to solve this expression. You remember the word expression. We talked about the word expression. Expression means whenever we are solving for something, we're putting signs in front of a number, or it could be a much more complex expression, and we'll be talking about that in further. But for the time being, our expression is plus plus minus minus plus plus 10. How to solve it? Time to put our first tip. Our first tip says 2 minus become 1 plus. Great. We have 2 minuses here, and we are making them 1 plus. And that becomes plus plus. Instead of 2 minuses, we have 1 plus now, and we had 2 more pluses, plus plus 10. Time to put our second tip. Second tip says, drop all the plus signs. Whatever plus signs you have in front of a number, drop them. Assume that those plus signs do not exist. You remember our example? No news is a good news. No sign is a plus sign. If you see a plus sign, think that sign does not exist. And if you do not see a sign, think that is a plus sign. Alright, so our second tip says drop all the plus signs. And the value becomes 10. So our answer to this expression is 10. So this was our answers to quiz, and I hope with this explanation and detailed answer you're able to understand what these negative numbers are, what the positive numbers are, and how on the number system scale we are moving. Now let's think about the same bagel shop example which we talked about this morning. I said I gave $3.50 at the bagel shop, and I gave actually $20, and then the bagel and apple juice costed me $3.50, and the guy gave me $16.50. When I think about bagel, it was actually one bagel. One number is an integer. Apple juice, there was one apple juice. It was an integer. But how about 16.5? We never talked about that, right? In our scale, 0.5s, half numbers, those never existed. So what are those numbers? They are not integers, definitely. So what those numbers are, and we will be talking about those numbers now, and we'll see how number system, big number system family is, and what kind of numbers are in that family. But before we do that, let's see what are the more number operation we can do. We talked about putting minus signs in front of number, like 2 minus become 1 plus, 2 plus, you can ignore it. But what will be the meaning if we put multiple signs between multiple numbers? How to solve that? So let's take one example. Minus 2 plus 5 equals what? This is another expression. Now these expressions are getting a little complex, and you see a little arrow sign here. That arrow sign says implies. Implies means the above expression can be rewritten as plus 5 minus 2, right? You can always rearrange numbers so long as they are carrying their signs. So minus 2 plus 5 equals plus 5 minus 2. So just to give an explanation about this sign, new sign which we are using, this is called implies. Remember this new sign, whenever you see the two lines and an arrow sign, it will be called implies. Implies means it means the same thing as what we talked before. Alright, so we can also drop plus sign. So plus 5 minus 2 actually is 5 minus 2, and we all know that 5 minus 2 is a normal mathematical operation. You can always say 5 minus 2 is 3. Wonderful. So this is what we saw here. Whenever we have multiple signs and multiple numbers, they actually go through a normal operation of addition, multiplication, division. So it's a simple operation. Even though we can drop multiple pluses in front of a number, the meaning changes when the plus becomes a part of two numbers. If you see plus in between 2 and 5, you cannot drop it. You cannot say 2 plus 5 is 25. You have to say 2 plus 5 is 5 plus 2, 7. Let's see our next example. What is 6 divided by 3? Now it's another sign, divide. It's a normal operation. 6 divided by 3 is our 2. We divide number 6 with number 3, it becomes number 2. And you can see our famous implies sign here, right? So what will be the value of this expression, 2 plus 6 divided by 2? Now the challenge here is, which one should be done first? Should we add 2 first with 6, or should we divide 6 with 2 first, because the meaning changes? Well, that is our real challenge that we will be dealing with in our coming sessions, in our coming classes, as to how to solve even more complex equations which involve multiple pluses, multiple minuses, and it has divide by sign, all those kind of signs. How to solve them? Now let's talk more about numbers. What we talked about so far about numbers is about integers. Integers contain positive integer, negative integer, 0, whole number. And our question this morning was, what is 16.5? We do not know what is 16.5, and that's what we'll try to answer here. We have our number scale here, and that number scale, the green side says 0 to plus infinity, and the red side says -1 to minus infinity. And we know our integers. Our integers are all the numbers on which arrow signs are present. 0 is an integer, 1 is an integer, 2 is an integer, 3, 4, 5. Similarly, on the opposite side, the red side, -1, -2, -5, -n, minus infinity, they're all integers. But then there are some numbers which are in between these numbers. For example, number between 1 and 2, 1.7. What does it mean? Number between 4 and 5, for example, 4.523. On the negative side, minus 3.35, and it could be any number on the negative scale, x dot y, where x and y both are integers. On the positive side, a dot b, again we can replace a and b with any positive values. How to solve that? And even before how to solve it, what do we call them? How do we name them? This is our magic board. This is called relational or rational numbers. Now, what is a rational number? A rational number is a number which can be expressed as x divided by y, wherein x and y both are integers. Now, either of those numbers can be a positive or negative integer, resulting the whole value into a positive value or a negative value, but any number which can be expressed as x divided by y is called a rational number. Let's see some examples. Our first example is 1.8. How do we call that 1.8 is a rational number? 1.8 can be expressed as x by y by saying 1.8 is actually 18 by 10. Or we can take two negative numbers. It can be minus 18 divided by minus 10. 1.8 is also 9 divided by 5. And 1.5 is also minus 9 divided by minus 5. You can see that in all these examples, x is one integer, y is another integer. 1.8 can be translated or described as x divided by y, so it is a rational number. Let's take another example. Minus 5.79. Minus 5.79 can be written as minus 579 divided by 100 or 579 divided by minus 100. I know it's getting little complex here, little too much detail here, but mathematics, as I mentioned, it's all about practice, it's all about understanding, it's all about going more and more in detail. As you will be practicing this, you will be realizing that these are not that complex. Algebra, mathematics is very simple. It is just a matter of practice. So let's see some more examples of what the rational numbers are. Okay, now going back to minus 5.79, it can be expressed as minus 579 divided by 100 or 579 divided by minus 100. And some more examples of rational numbers are minus 25.8769. I mean, it could be any number, I'm making it up, or my $16.50, that's also a rational number. 5.25 and 8998. You can just go crazy about putting a number on the left hand side, you can go crazy about putting a number on the right hand side, so long as you can express a number in the form of x divided by y, it is a rational number. Let's talk more about numbers. We talked about rational number. There is a special number, square root 2. Now, if you go and do some research on websites, if you do some research on books, you will find that this number, square root 2, cannot be expressed as x divided by y. Now, what is that number? That number is called an irrational number. Numbers which cannot be expressed as x divided by y. Now, there is a little history behind this square root 2. I must tell you before we move forward. This number is called Pythagoras number. This number was discovered or maybe realized by a famous mathematician, Pythagoras. What he did, while he was trying to see what is the correlation between the two sides of a right angle triangle and the diagonal, he found out that the size of the diagonal is always squares of two sides and then sum them together and then take the square root. So if, let's say, a triangle with each side 1, the diagonal will be 1 square plus 1 square, and then do a square root of that becomes square root 2. But we are not talking about that right now, don't get confused with it. It is just to give an example. This square root 2 is called Pythagoras number. Just for your knowledge, just for your understanding. Now, square root 2 cannot be expressed as x divided by y. So what is that number? Do we have some more numbers like that, or is it just one number we are talking about? No, we have a lot of more numbers like that. For example, square root 7, square root 11, square root 13. There are a lot of numbers, and these numbers cannot be expressed as x divided by y. Our famous number pi, and we'll be talking about pi, but these numbers are called irrational numbers. Alright, our magic board, it talks about irrational number now. Anything which cannot be, remember that term, and I hope you are noting it down with a paper and pen in your hand. Anything which cannot be put in form of x divided by y, where x and y both are integers, is called an irrational number. Just to take an example, square root 2. This morning only I was looking at a website, and they had the next 5 million digits of square root 2, and still it is endless. What does it mean? Square root 2 keeps on going, keeps on going, keeps on going. You can actually spend your whole life finding the next number of square root 2 after decimal points. So for example, here we have 1.4142. It keeps on going. I can keep on spending the whole program on telling what is square root 2. These numbers are called irrational numbers. They cannot be expressed as x divided by y. This number cannot be expressed as x divided by y. Now, some more examples are square root 3, and square root 3 is 1.73200508. I can keep on going. This number is again infinite, the same infinite sign after decimal. Now, when I say infinite, the count of numbers after decimal are infinite. These kind of numbers are called irrational numbers. There are some more examples. Square root 7, square root 11, square root 13, and so on. So now let's get back to our same number scales and see. We have learnt about integers, we have learnt about rational number, we have learnt about irrational numbers. Integers are the numbers, the actual numbers between minus infinity to plus infinity, with 0, 1, 2, 3, 4, and that keeps on going. From negative side, it is minus 1, minus 2, minus 3, minus n, minus infinity. Rational numbers are numbers which can be expressed as x divided by y, and hence they result into a decimal value, and it is 1.7, 1.75, 1.42. On the negative side, minus 5, minus 4.75, those numbers. And then we also saw a third category of numbers, which is irrational numbers. Irrational numbers are the numbers which have a decimal value. For example, square root 2 has a decimal value, approximate decimal value, 1.42, and something keeps on going, but it cannot be expressed as a rational number. It cannot be expressed as x divided by y. So let's look at the whole family here, the whole family of numbers here: integers, rational numbers, and irrational numbers. That makes a much more bigger family, and the bigger family is called real numbers. Whenever we are talking about real numbers, now we are talking about a new term, real number. So in mathematics or in algebra, whenever we are talking about real number, talking about a much broader category. We are talking about numbers which are integers, numbers which are whole numbers, are rational number or irrational number. The whole big family is called real numbers. Now this family does not end here. The family keeps on growing, and we'll be talking about more and more numbers. This was just an introduction to numbers, and as I'm getting the sign from my director that the time is going up,